Good afternoon, my name is Dusty Vyas. I'm one of the senior scientists at LGC Biosearch Technologies, and I'm part of the scientific support team. I'd like to introduce Katherine Steele and Dr. Mohammed Arif.
I'm Katherine Steele. I'm a senior lecturer at Bangor University, and I've got over 20 years experience of crop breeding and marker-assisted selection.
I'm Mohammed Arif, and working as a deputy chief scientist at NIPG Faisalabad, Pakistan. And I'm working for the improvement of basmati rice for abiotic and biotic stresses using different genomic approaches. And I did my PhD from International Rice Research Institute in 2002.
Thank you very much, Dr. Arif. Katherine, could you give us a bit of introduction to the Innovate UK and the Rice project, if that's possible?
Yeah, so the Innovate UK project started about 5 years ago, and we were working with breeders in national programs, initially just in Nepal, and then with breeders in India and Pakistan. And basically, a single improved rice variety can increase harvest value by millions of pounds a year, and it can then go on to benefit farmers and their families and improve livelihoods. So it has huge impacts on development, international development. So molecular markers are a tool that are used, but a lot of breeding programs, certainly the national programs we were working with, and also one of the small companies, seed companies in Nepal, weren't really able to use them to their full effect. And the small breeding company wasn't actually using markers at all because they didn't have their own lab. So that's why we felt that this project would help that by actually allowing those users access to the new KASP technology, which is much more flexible and allows the smaller users and the well, it just gives so much more flexibility to breeding programs.
And what sort of targets are you looking at when you're trying to apply molecular markers?
Okay, so we've actually, in designing this program, we asked the breeders what targets they were most interested in. So there's a list of markers or types of traits that breeders are interested in. So you've got things like aroma, which adds economic benefit. You've got things like drought tolerance. So we've got markers for root length with salinity tolerance and other abiotic stresses. But the big one is the biotic stresses. So the two big important diseases are bacterial leaf blight and rice blast. So we've had, and because there's so much information out there about where those markers are in different genotypes, we've been able to take all that information together and look at different genomes to try and work out which are the most likely ones to use that will actually be beneficial in farmers in farmers' fields ultimately, but in breeding programs leading up to those varieties.
Thank you. So, I mean, we're talking about Southeast Asia, we're talking about the challenges that all the breeders are facing. So we have Dr. Mohammed Arif here, who can talk about the specific challenges that are faced in Pakistan.
Yeah, so just give me a little time. I will just go briefly about the importance of rice in Pakistan. Pakistan produces around 6.5 million ton of rice per annum, and of which 4 million ton we export to different countries, to different regions like Southeast Asia, in Africa, to European Union, and to Middle East. And of this 4 million ton, only 600,000 ton is from basmati. The rest is of non-basmati or coarse varieties. And if you talk about in terms of the foreign exchange, we earn around $2 billion of the foreign exchange with the export of rice. And of this $2 billion, around 0.8 to $1 billion is from basmati rice. So you can see, although the quantity of basmati rice is very, very less as compared to non-basmati rice, but the reason of getting premium price is that basmati is very high quality premium rice because of its aroma, because of its long cylinder, extra long cylinder grain, and it's soft, and extra is when we cook it, we get more than double of the size of the grain. So that's why it gets premium price, and we get around more than double than the non-basmati or coarse rice. So the problem we are facing is that the exporters of Pakistan, they aim to increase their export to around $4 billion till 2030. So it's really a challenge for the breeder as well, that we have to increase the basmati production. So basmati production means that we have to increase its yield, but we have to keep or maintain the grain quality, because the quality of the basmati is the one which fetch the premium price. So that's why it's really very difficult to increase its yield besides keeping its grain quality intact. So, and the next challenge is that if we go for the increase in yield, then we face different biotic and abiotic stress challenges. In biotic challenges, we really face bacterial leaf blight. It's a really threatening diseases. And nowadays we are facing brown spot and leaf folder. If you talk about in abiotic stresses, these are also, although these are secondary one, like drought, submergence, and salinity. But nowadays, what we are facing is, which are now prime importance for us more than the drought and salinity, is the heat stress. Because of the heat, at the time of the maturity, at the time of the pollination, the heat, there is so much, the weather is so hot that pollination could not occur. So now we are trying to put that heat stress after BLB in the second number. So introgressing these genes into our basmati rice variety is really a challenging job. So really we are facing these challenges nowadays.
So how did you start out using, the use of molecular markers? And molecular markers have been around for at least 30 years now. So how did you begin to apply molecular markers in the early days?
Well, as I mentioned that I did my PhD from International Rice Research Institute, and my main objective or my main thesis was to introgress bacterial leaf blight resistance genes in basmati rice, and also to maintain its grain quality. So at that time I started to use SSR markers. When I came back in 2002 after finishing my PhD, nobody was doing this molecular breeding in Pakistan. So I was the first one who started molecular breeding in Pakistan in rice.
Wow.
And then I started to collaborate with the International Rice Research Institute. And then I requested them to get for the donor lines, which we call IRBB lines, which are near isogenic lines having different single and double bacterial blight resistance genes. So from there, I started to work on molecular breeding around in 2003.
And so what were the challenges? What sort of challenges did you face with using that technology in particular?
Yeah, as you mentioned that SSR means I worked on during PhD, I worked on SSR. So SSR was my favorite marker. I before my PhD, I was working on RAPID. I was working on AFLP. I was working on other SSR markers. But then when I started SSR markers, I really found it's very, very, very easy for me because they are multi-allelic and they are easy to detect. And you can simply run it on the gel. But then by the time when I was doing these things, then there were some markers, SSR markers, which were showing very, very low small differences between the bands. So it was really challenging for me that how could I detect those small differences on the gel. Then I also used a page, polyacrylamide gel electrophoresis, but you know that casting a polyacrylamide gel is really a task, really a challenging job.
It's almost an art form. It's almost an art form, producing polyacrylamide gels.
and even though when you cast the gel, then you are not sure when we are running it on the gel, it will be leaking. So you got the leakage problem also. Although I tried many good companies gel apparatus, but I found the same problem in each and every one. Some were really, they were good, but by the passage of time, the problem emerged after some time because of the sealing, the degradation of the sealing material. So then when in 2017, when Katherine, she approached me that we are working on KASP markers. Before that, I was reading about KASP, and I became a little bit fascinated about KASP. That wow, what the mark is that? Although for SSR, I went through the high throughput. I was using capillary electrophoresis on Beckman genetic analyzer, and that was very easy for me. I use also ABI and Beckman, but Beckman, I thought that Beckman is more easier than the ABI, so I started on Beckman. Then again, this problem started. There were some gel problems. The polymerase was not good, and sometimes they have very their expiry was very means 2 to 3 months. If you don't have enough samples, you will lose those accessories or those consumables. So when she approached me, Katherine, then I found that this is good time to switch from SSR to LGC. Although I was a little bit confused. That how could it be possible for me to get the genotype of these samples. Then I started to read the material. Then what are the possibilities? Then I was thinking that I will try to set up a lab to get all the sophisticated apparatus over here, and then get the plate reader and everything. And I will ask Katherine to send me the assay, only the KASP assay. But when the first time I got the leaf boxes from LGC, and they asked me, then in that boxes they also sent me the punches, those we call leaf punches. At that time, before that, I also visited the Bangor, and then I had a conversation with the John. So he was describing his experience to Katherine and me, that when they went in Nepal, they went into the field, and they sat all the day in the field, and they were taking the leaves and then punching it, putting it in the leaf boxes. Then I thought, it's really cumbersome job. It's not an easy job, because I don't know what the weather in Nepal is, but sure, in Pakistan, in Faisalabad, in 45 to 48 degrees centigrade, it's not easy for me to sit on the field, take the leaf, punch it, and put it into the well. So I thought, no, this is also not a good job, not an easy job for me. But when I got it, then we tried to manipulate it. Instead of sitting in under 48 degrees centigrade, we went into the field. We took the leaf samples in a Ziploc bag, came back. Sorry, Katherine, this is a different secret for me. And so we just put it in the Ziploc bag and then came back in the lab. Then we punched with the punch, and then we started to put it in one by one in the well. So that became easy for us. Because if you sit in the 48 degrees centigrade and started punching at that on the spot, it would be not easy for us. So that became easy for us, and then I sent it. Then I was not sure whether, because I just manipulated it as per instruction. I did not do what I have been instructed. So then I was not sure whether we will get the good data or not. But when data arrived, I was really surprised that data was perfect, fine. Means not 100%, but at least we got 97 to 98% samples genotype very perfectly. So then I really surprised that this is a very easy job. Instead of doing all these things, making page or making agarose and putting it in the PCR reaction plates and everything, instead of this, just punch it in the leaf boxes and send it to the LGC. The rest will be taken care by the LGC. That's fine for me. And within no time, I got genotype of, I think, more than 3,000 samples with around 2,500 KASP markers. So it means that LGC is KASP markers are far to working on with KASP marker is far easy and comfortable as compared to SSR. So that's why I now became fond of KASP markers.
That's great. That's great. Thank you, Dr. Arif, for giving us that perspective on, you know, how the difference from SSRs using the old technologies, the efficiency and the ease of which you can use the plant collection boxes and the LGC services. So can I go to Katherine now and talk about your partnership with LGC and how you feel it has helped you achieve your objectives and accelerate your breeding program?
Well, yeah, we have in the project we have 3 breeding programs. Well, actually 5 breeding programs. We've got one in Pakistan, which we've just heard about from Dr. Arif. We've got one in India, led by the University SKUAST, and we've got 3 in Nepal, 2 of which are through the Nepalese National Agricultural Research Council, and 1 which is with a private company known as Animal View. And for all of them, I think they have found KASP, certainly using the service from LGC, the all-inclusive service, they found that very efficient, and it enables them to make selections easily in material that's growing in the field. The turnaround, I think everybody finds fast enough, and the quality of the results is informative. And so we've actually managed in the Nepalese Agricultural Research Council projects for in 2019, and they were the ones who started first in this, that 33 potential new varieties went into pre-release trials from 3 different crosses, and then by 2020 at least 2 additional sets of material from 2 additional crosses also have gone into advanced trials from that. And yeah, they love the fact they can send the leaf material away and not have to do anything in the lab beyond sending those boxes. And they find the data spreadsheets that come back, we do need to help them a little bit to start off with to get the format right, so we can line up the markers in the order on the genome and colour code the genotypes to make it easier for selection. But once that's done, it's very, very straightforward to look through to use basically Excel spreadsheet manipulation, so pivot tables and so on, to actually work out which lines are the ones to go for and which are the ones to reject. And it's really good for multiple stacking of multiple resistance genes. We've been trying to incorporate VLB resistance and blast genes in the Nepalese programs as well. So yeah, it's really good.
Oh, yeah, I think it's great. So looking ahead, you know, we're all looking at how these technologies can have an impact on agriculture and help local groups use the latest technologies and actually have access to them. So this is a question to you both. Where do you see the future outlook for the application of KASP markers?
Who's going first?
Sorry, did I say that wrong?
No, who's going first? Sorry.
I don't mind. Dr. Arif, would you like to go first?
Okay, so for me, as I mentioned, that really I am the person who really stick for one thing and could not let it go. But after using KASP markers, I thought that I'm thinking that I should switch all my genotyping works to KASP markers if I would be allowed to work on this one, because as I mentioned that I was just in the initial stage of the project. I was thinking that I will just go with 1 or 2 population on which I am working for bacterial blight resistance. And then when I got some result, then I thought it's now good idea to include some other traits like for drought and for salinity. So for drought, I had already developed some recombinant inbred lines. So I thought it's good for me to get those real population genotype with the KASP markers, because once that would be genotyped with the KASP marker, it would be easy for me, because that population is made from one susceptible parent and one drought tolerant parent. So then I would be able to look at the genes which are really promising in the basmati background, because one of the parent is basmati, one was super basmati, which is susceptible to drought. And then I took advantage of this project, and then I also, because I have a collection of some rice land races from Pakistan, and I have some collection from USG Minico rice lines. So no one has yet worked using KASP markers on these mini core rice collection from USDA and from rice land races. So I got around 250 markers. I got genotype with these land races and USDA mini core rice lines, and I'm trying to identify some lines. And me and Katherine, when we identify some bacterial blight resistance genes that were already there. So some of the haplotypes which were already reported, but beside those, we identified some other haplotypes which in XA5, and now we are working on XA13 as well. So it was interesting for me that some are reported and some are still unreported. So with the help of KASP markers, I identified some haplotypes which are really segregating with the XA5 markers. Whenever, because there are some reported literature in the XA5 specific markers are there, specific primers are there. But when you look at the primer, there are only 2 or 3 SNPs which are segregating with those one. But with the help of KASP markers, we identified that no, there are 7 to 9 SNP markers which are segregating along with this one. So we can make it sure that XA5 is really introgressing into our desired genotype or not. Similarly, for XA13 and XA21 markers were already published and people were using that XA21 markers. But when I look at my KASP marker genotypic data, then I found that that specific available primer from the literature, they are not giving me that specific XA21 primer that I am looking for. And in my germplasm, I was expecting that this germplasm is having XA21. But when I look at the data, in the screen data, there is XA21, but that specific marker is not showing the XA21. But when I look at the KASP marker data, I found that that specific SNP is present. It means that KASP marker are more reliable than the available primers or available SSR markers. So this is how we can detect many SNPs for different target traits, like for BLB, for drought, and now I hope that we could continue this work with Katherine. So we will start to work on heat stress. And beside this, I also shared this data with our director, and he was so much pleased that he also now became fond of KASP. So we at NIPG, we are working on livestock.
Wow.
And they are also working on the CRISPR Cas something. But on the livestock, we are now in the process of getting KASP platform over here.
Wow.
Because yeah, so on the livestock we are now going ahead to work on the KASP markers, and within 1 or 2 months we will be asking LGC to provide us some actually to design some primers for livestock, which we have already identified from our GPS. So we sequenced the buffaloes and cattle of Pakistani origins like Neeli, Ravi, and others, and now we are identifying the SNP primers, SNPs, and from those SNPs we will convert them to the KASP markers, and hopefully by within 3 to 4 months we will be having that KASP platform over here at Niji as well. Brilliant. So this is how I think this is the success of this project, that I explained all this to my director, and he became very much convinced that we should have this KASP marker technology over here at Niji.
Well, give me a shout when you need help with that as well, so we can go through that.
Sure.
And Katherine, so your future outlook, you know, the use of KASP markers in haplotypes, maybe even the potential to use it in something like genomic selection. Do you think that's a possibility?
Oh, definitely. So far, this project has developed and validated around about 5,000 new KASP markers. So that's the kind of numbers that you'd need to be able to run genomic selection with. And I think genomic selection needs to be tested with this set of markers. But we've also got designs for over 1 million KASP markers that could be used. So definitely, I really do want to see genomic selection used in the future in rice with these markers. I'm also looking forward to the development that we're working on in this project now with yourselves at LGC for the new database, where it should be able for potential users to search for potential KASP markers, either these validated ones or the designs that haven't yet been used, which they may feel would be useful in their programs. The designs have been developed by using over 130 different genotypes, whole genome sequences from a range of different types of rice. So in theory, and we're finding in practice that we're getting 90% of them working in any variety that you just happen to that hasn't been the genome sequence analysed to actually design a specific primer for it, because we've incorporated all variation within those 130 or so lines into the designs that we've got in our set of design. So that should make it flexible for people to try out these markers and see whether they work in their particular breeding programs and particular sets. But the other thing, going back to what Dr. Arif was saying about looking at sets of diverse varieties, that's also something that my colleagues at SCUAST have been doing, and they have looked at a set of Himalayan rice varieties, and they've actually been able to use these KASPs that we've developed to work out the genetic structure, population structure within that set of material, and identify lines that could be useful as parents for breeding for specific adaptation in that region. And so that diversity study publication should be coming out soon. And along with that, and hopefully when we've worked, for example, with the XA5 mapping program that Dr. Arif mentioned, we should have more papers confirming that KASP markers can be absolutely linked to traits and used in those ways forward, so that really these KASP markers need to get into the literature in the same kind of way that SSR markers have been predominant in the literature. And as we go forward, I think that will raise their profile and enable more people to have the confidence to use.
All right, thank you very much. So, I mean, from this discussion, we've seen how KASP markers have been applied, how it's changed from using SSRs to KASP, which I think is important in the movement and development of rice varieties in the future. Because, you know, we're all facing the challenges with climate change, environmental change, even, you know, what we're experiencing at the moment with the pandemic. The need for precision agriculture is going to be needed for for now and in the future. So I'd just like to take this opportunity to thank you both for taking part in this unusual chat. I hope you've enjoyed it as much as I have. So thank you very much.
Thank you.
Thank you. Thank you.